Hello everyone, let's continue with the regression analysis. Next, we will go to the command sheet and write regress and dependent variable, and we'll select all the remaining independent variables. After running the regression analysis, these are the results. Now let's interpret the results. First, we have to see the probability must be greater than f. That is, p-value must be less than 0.05. If the p-value is less than 0.05, our model is significant, otherwise it is insignificant. So if we see the raw data, the model is overall significant. However, the independent variables priced in dollars and uh, competitive price is insignificant. Now we'll run the stationarity test. Defuller, rooms rented, trend, lag, 0. Let's run this command. This test is for unit root test or test of stationarity. Oh, we have not set the time variable. TS set T. Okay, we have set now. We have now set time variable. Now we will run this regression. So Z T value, or we can say P value is greater than 0.05 means the data is non-stationary. Further, we can verify this from the graph. Let's go to our worksheet and see the graph. See the graph. The data is non-stationary. We can see from this from the graph as well, and the test also support the evidence, right? Now we will transform the data. Either we will take log transformation or differencing. First, let's see if we take differencing. We can either generate variable or default d dot variable name. What will happen from this is difference will be generated. Now let's run the test. So p value is less than 0.05 means differencing transformation with differencing is very efficient for this data, right? Either we can take log transformation, square root transformation, or differencing, right? So we have taken differencing. Now we will copy this in the Word file, unit root test or test of stationarity. Let's copy the results here. Okay, so we have all the results here. Either you can print screen or copy the results in Word file, or you can copy the data as it is. Okay, now we will write some analysis from the above ADF test or Dickey-Fuller test. We can see that the data is non-stationary, and we will not reject null hypothesis as p-value is greater than 0.05, right? And alternative hypothesis is uh, not also not accepted, right? So we'll just write this thing here. We do not reject null hypothesis as the p-value is greater than 0.05. Hence, the results indicate that the data is non-stationary. Therefore, we cannot run regression analysis or use the results of regression analysis run on the raw data. Further, we will write the transform data analysis. Further, we have transformed the data using differencing method, whether the data was transformed. First reference. Here we will reject null hypothesis as p-value is less than 0.05 and our data is now stationary, and we can use this data for regression analysis. Right? This is the analysis. Or you can write further things as well related to your variables. Now we will run another variable, number of tourists. So this is also non-stationary. Further, we can validate this from the graph as well. We will use the differencing method. We'll run d fuller with d dot variable name that results become significant. So our data, our variable is now stationary. Let's do it with all the remaining variables. I will remove all the spaces. Okay, same, the data is non-stationary. We'll take differencing and then it becomes stationary. So differencing method is very good for this type of data. However, for some data, log transformation can be very helpful. For some data, differencing a square root method is applicable, right? Same with the price in dollars, d dot, or it's command, d dot. Okay, it becomes. So sometimes data becomes stationary in first differencing, and sometimes it take 2, 3, or up to 12, 20 differences to make the data stationary, that we can also validate from our ACF and PACF plots. Okay, now all our data has become stationary. Now we'll move towards calculating the errors. Let me walk you through how difference is calculated. So we'll just take the difference of new value minus the old value, right? And with every differencing, an observation is produced. Let's see this with the log variable. We will generate log variable for. Okay, first let me run some calculation with differencing. So first difference is calculated. New value minus the old value is the difference, and we will copy all the data. Then second difference is calculated on the basis of first difference, right? So whatever the first difference is, we will subtract new value minus the old value, and the second difference is generated, and so on and so forth. So with every difference, the observation will be reduced. So we cannot apply a differencing method on number when the number of observations are very less, like 20, 25 observations. But when there are hundreds and thousands and millions of observations, we can use differencing method up to n number of times by when our data becomes stationary. Okay. Okay. So this is the logic behind differencing, and you have already performed the log transformation and square root and everything. Okay. Now let's run some. We'll generate a log ln. Let's say competitor price is equals to formula ln multiply by competitor price, or in the bracket competitor price. Remove all the spaces, and it is generated. Now we'll run decay fuller test with ln competitor price, right? Change the variable and run the test. So the data is still non-stationary. For this kind of data, log transformation is not effective. However, differencing method is effective. So you have to check and like trial basis that which method is more suitable for your data. right? We will now run regression again on the raw data, right? And then we'll run all the errors. So be mindful, whatever the last regression model you will run, all the errors will be calculated on that model only. Okay, so if we calculate regression on the raw data and then run all the error tests, it will be for the raw data errors, right? And if we will regress the transform data and then run the regression model and then calculate all the errors, it will be of the transform data, right? So I will just d dot with every variable name. So differencing will be calculated, difference data will be calculated. I'll just run the regression analysis on the raw data. I will first do ssc install jb. Okay, first predict residuals. They're just errors. Now ssc install jb. For Jagpara test, we have to install the function first and then run the Jagpara test. So jb reset. So Jagpara test shows the normality of the data, right? If the p-value is greater than 0.05, then we will reject null hypothesis as, that the data is not normal, right? Jagpara test is done for the normality. I will copy the regression, highlight the key uh, points which we need to write in our analysis. That is p-value, errors, r square and adjusted r square, and coefficients and their p-value of all independent variables. Okay, I'll take this on the next page. Regression model 1, that is the regression model on the raw data. Okay, let's highlight the key functions or key points that we will use in our analysis. P-value, r square, adjusted r square if you want to write it in your analysis. Sum of square errors, mean square error. Okay, now coefficients. 39, there are 39 observations in this data. Okay, I will highlight all the coefficients that we will be using in our model, and the p-value of all variables, all independent variables. So just y is equals to a plus bx1, bx2, bx3. Number of variables, number of independent variables you are using. So a is the constant, b is the slope. Just do a little bit of formatting of the model. Okay. Now we will write all the coefficients, right? Y is equals to, this is a constant a, negative 618.26 plus the first bx1, then second independent variable, third independent variable, and then fourth independent variable. Just copy x from the above equation, write this here with the variable x1, x2, x3, and x4. We have one dependent variable and four independent variables. This is x4. Okay, this is a regression model, and the now we will write the analysis of the coefficients. So constant is negative, and then uh, all the other independent variables have a positive relationship with the dependent variables. So from the above equation, number of tourists has positive relationship with rooms rented. That is, with each new tourist, rooms rented will increase. The rooms available has also positive relationship with rooms rented. Price and competitive price is also positive relationship with rooms rented.